Hi everyone. This video is going to give you some information about JJ Thomson and his experiments with the cathode ray tube. JJ Thomson was an English professor of physics, and he is given credit for discovering the electron about 50 years after Dalton proposed his atomic theory. This is a picture of a cathode ray tube, and this is the instrument that JJ Thomson did his experiments on to determine that an electron actually existed, and more specifically, he discovers the charge to mass ratio of an electron using this device. So here's a closer picture of the cathode ray tube. I'll just describe how it works, and then on the next slide I'll show you specifically what all the parts are. This is a cathode in the cathode ray tube. This is a negatively charged electrode, so this would just be a piece of metal. There's also a positively charged plate. This would be another piece of metal here. And the charges are placed on these two pieces of metal using a high voltage source. So this would be the equivalent of a really, really strong battery. Inside this cathode ray tube, it's a closed container, usually glass. There's a gas, but at very, very low pressure. And when the voltage source is turned on, what happens is some of the electrons get stripped off of the atoms in the gas, and they travel towards the positively charged plate. Because electrons are negative, so they're going to travel towards the positively charged plate. If there happens to be a hole in that plate, some of the electrons are going to have so much momentum that they're just going to travel right through and produce what we call a cathode ray, which is simply a beam of electrons. You can't actually see a cathode ray, so at the end of this tube, do you see this black coating? It's actually probably white, to be honest, but it's covered with a compound called zinc sulfide. And zinc sulfide, when it's hit with electrons, fluoresces, so it produces a little spark of light, and that's how we're able to track the direction of the cathode ray tube and where it's actually hitting the zinc sulfide. This slide defines the parts of the cathode ray tube. The cathode, again, is the negative electrode. The anode is the positive electrode. That's the electrode that the electrons are traveling towards. The cathode ray is a beam of electrons, and the voltage source produces a strong negative and positive charge on the two electrodes. This is a picture of the cathode ray tube that we have in our classroom. Ours doesn't actually work, but I wanted you to see a picture of it. The difference between this cathode ray tube and the one you saw in the previous slides is that the beam, that kind of green beam that you see there, is sliding across a piece of metal that's coated with zinc sulfide. So you can actually see the beam as it travels across the cathode ray tube. So you can see literally the beam of electrons hitting the zinc sulfide, and that's why you see that light color. If the zinc sulfide wasn't there, we really wouldn't see anything. This is a picture of William Crookes. He developed the cathode ray tube. It used to be called the Crookes tube prior to JJ Thomson working with the device. Crookes also did several experiments with the cathode ray tube, but it was actually JJ Thomson who's given credit for determining that the electron existed and what its charge to mass ratio. These are some of the experiments that JJ Thomson did, and you can write down this information down at the bottom of your notes. One of the experiments that he did was he held a magnet near the cathode ray, and the effect was that the beam ended up being deflected. Here you can see the beam going down. And what Thomson was able to conclude is that the beam was made of charged particles, and therefore it couldn't be light, because light would have never been deflected by a magnet. He also put positively and negatively charged plates near the beam, and the effect was that the beam always deflected towards the positive plate. So even if he switched the two plates, the electrons always traveled towards that positive charge. So what he was able to conclude from this is that the beam must have been made of negatively charged particles. So now we know there's a subatomic particle and it's negatively charged. He then placed positive and negatively charged plates and magnets near the beam simultaneously. And he would change the charge on the positive and negative plates, and he could change the strength of the magnet, and he was able to very specifically control and measure the deflection of the beam. And it was by taking these careful measurements that he was able to conclude the exact mass to charge ratio of the electron, or how heavy it was relative to its charge. He couldn't actually identify the mass of a single electron or the charge on a single electron, but he was able to get the relationship between those two numbers. This is a model of the atom by the late 1800s. This is called Thomson's plum pudding model. It's a little fuzzy in this picture, but the pink area with the little pink positive charges is just a sphere of positive charge, just kind of this blob of positive charge. And embedded in that would be the electrons. Those are those little purple-blue circles with negative charges in them. Thomson called this the plum pudding model because he wanted sort of the everyday man to understand what it looked like. And people in England were familiar with plum pudding, which was this pudding that had plums embedded in it. I think it might be easier for us to understand if you think of it as maybe rice pudding with raisins. So the rice pudding part would be this positively charged blob of stuff, and then embedded in that you have the raisins, or the negatively charged electrons. So those are the notes on JJ Thomson. At this point, you might want to click on the animation that I have on Moodle for you guys on the cathode ray tube. But you definitely want to do the JJ Thomson Moodle homework. And if you have any problems with it, just see me in class. Talk to you soon.
Made with Doodlecast Pro.